Hey, what's up, people? It's KG.codes. I'm back on here again to do another coding challenge from LeetCode.com. This time I'm gonna do a medium problem. I hadn't done a medium problem in a long time. I've been doing mostly easy problems or problems that's considered easy. So this time I'm gonna do a medium problem. I'm gonna see how it goes. I'm hopefully, I need to reset that. Yeah, I'm hopefully gonna be able to get through it from just pure memory. I just did the problem, so I'm gonna see if I can do it again. We'll see how it goes. I'm gonna see if I can go through the thought process, explain what I'm doing, answer questions. I'm gonna try to pay attention to the chat, stuff like that. But this one's gonna be a little bit harder because it's a medium problem, so it takes a little bit longer to do. In the interview, you probably would need like 20-30 minutes to do this type of problem. It's probably how much the interviewer will give you, but it just depends on the company that you're going for. So yeah, I hope some people jump in here and hopefully we can try to learn something together. Hopefully we can try to work through the problem together. These problems still get asked a lot in interviews. They are really difficult. These are kind of the gateway to getting programming jobs. Historically, it's starting to change now. Some companies ain't asking these kind of questions anymore, but a lot of companies still do these coding challenge style questions, data structures and algorithm style questions. And one of the best places to practice those problems is LeetCode.com, like I'm on right now. And so yeah, without further ado, I'm gonna go ahead and just start jumping into the problem. I'm gonna try to pay attention to the chat. Sometimes it's a little hard with how these problems are, how much I have to focus on these problems. It's hard to jump in the chat and figure out, what people are asking, but I try my best. So y'all help me out, comment and stuff like that, and we'll go ahead and get started. So this problem is called longest substring without repeating characters. It's a medium level problem. So if you know LeetCode.com, they have medium level, easy level problems, medium level problems, and like hard level problems. And so this is a medium. This is one of the first mediums I'm doing live. So, just pray for me that I get through this unscathed. But we'll see how it go. So yeah, this problem is called longest substring without repeating characters, medium problem. I don't have the money, the paid subscription to see what companies, but I think from my notes, I think Amazon asked this question, or at least they used to. So it goes as such: given a string S, find the length of the longest substring with duplicate characters. Given a string S, find the length of the longest substring without duplicate characters. And then they give a couple examples here. abcabcbb. The output is 3, where the longest substring without duplicate character is ABC. So ABC is the longest substring you get where each character, there's no duplicate in it. And they can't be a duplicate anywhere in it, not just next to each other, but it can't be any duplicate anywhere in the substring. So ABC here is another substring. CABC is not a substring because you got a C, you got two C's. Of course, BB is not a substring. BCB is not a substring. So the longest possible substring here is ABC or ABC, which are both 3. And what they want you to output is the length of the longest substring without duplicate characters in it. So if you look at the string example 2, BBBBB, the longest substring is 1 because everything's a B. So you can't even get to 2 because you get a duplicate. So the longest substring without a duplicate is just a single B. Because it's all B's in this string. And then you have this like PQ or whatever. The answer is WKE, which is in the middle here, because everywhere else is shorter substrings. This is the longest possible substring before you run into any duplicates. And it says, notice that the answer must be a substring. PWKE is a subsequence, not a substring. So you can't like skip characters or something like that. You literally, they have to be a substring is characters that are next to each other, and you can't have any duplicates throughout that whole character. So yeah, come back to the comments. Somebody said I was sliding I slide and window this bit. Yeah, I think you're on the right track. I did this problem so many times. I think this is a problem a lot of people do a lot of times, because I believe when I was interviewing for Amazon, I believe this is one of the problems they asked. So I think a lot of people end up doing this problem. So yeah, I'm going to go ahead and jump into this one. So if you ever seen me do these before, appreciate the comments, by the way. If you ever seen me do these before, you know I like to try to think through the solution first, come up with sort of a plan verbally, check in with the interviewer to see if that plan is, makes sense to them, and then proceed with the code. It's best practice not to jump right into the code, because you don't give the interviewer a chance to try to help you. A lot of times the interviewer will help you if you talk through your thought process with them before. If you try to ask clarifying questions, if you try to just work with them, sometimes they'll stop you from going into a bad path. But if you just jump right into code, they really not going to try to stop you. You know what I mean? They're not going to handhold you that much. So what you want to do is try to talk through your solution first. But yeah, I didn't read the constraints first. Sometimes you get these constraints in the interview, and sometimes the interviewer won't give these to you, and you have to ask clarifying questions to get them. So this problem, is pretty simple. I understand from the examples and the problem statement kind of what they're asking me to do. So I don't really have clarifying questions about the problem itself. Some problems are more complicated as far as the question itself. You might get confused by what it's asking you. I know what it's asking me. Now, doing it in code is a whole nother story. But then you got the constraints, where you might have to ask them about the constraints. Like, one important thing is, it says S consists of English letters, digits, symbols, and spaces. So, it's just an important thing to know what you're dealing with. So these could be uppercase characters, lowercase characters, digits, basically anything within the keyboard sort of assets of English, like English keyboard. And then this is important too, to know what the length of the string is. So we see that the length of the string can never be higher than 5 to the 10 to the 4th power. So this basically just means that this is within the range of our programming language. I'm using JavaScript. And so I'm guaranteed, at least within this confines of this problem, with 5 to the 10th power, it's not enough for me to overload the programming language with the amount of data within the variable, or overflow. And then this is important. Like, can a string be 0? You might ask the interviewer this. They may not give it to you. You may ask, hey, can the string be a length of 0? Like, is a 0, can one of the problems for this, one of the inputs here, it's all about inputs and outputs for these types of problems, for these coding challenge types of problems. And these input can be anything under the constraints. And so this is an important thing to know, that the length can be 0. So we need to handle that case. And so that's like handling edge cases. And sometimes in these problems, there'll be edge cases based on the constraints that you have to handle. And sometimes if you detect that there's a weird edge case, you can ask the interviewer, and they might help you out and say, hey, don't worry about that. Don't worry about this. And they'll give you constraints that'll help make the problem easier. So here, LeetCode gives you the constraints, but I'm just trying to make the point that sometimes in the interview, you might have to actually ask for the constraints and kind of get the interview to help you. So anyway, talking through the solution, like somebody said in the comments, I can't remember who that was. Let me see. Somebody in the comments said a sliding window. So I'm going to backtrack a little bit and just think about the problem from just how would I solve this in my head if I had to do it with pencil and paper or something like that. So if I'm looking at example 1, I need to find the longest substring without duplicate characters. So how I would look at this is I would just start from front to back and just go through each character and just add up a substring without duplicates, and I would probably save in my head the longest substring without duplicates in it in my head. So I would go through, I would say I got A, B, C, there's no duplicates. Then I ran into A again, so there's a duplicate. So I know that I at least found A, B, and C. That's a length of 3. And I found that one, and that's my longest one I've seen so far. So I would kind of store that somewhere in my memory banks, that I've seen of one with at least 3. But I know when I hit this, that I found a duplicate. So I kind of have to start from here and then kind of start over, like removing this out because it's a duplicate of A. And I would kind of start looking here to see, okay, I got B, C, A. Then I hit another B. So I know this is another 3 that I found. So I'll say that in my banks, but it's not higher than what I already found. So I know my max length that I found is 3. And then I would take B out the equation. And then I would start with C, A, B. Then I get another C. So I would go back here and say, okay, I got another 3, but it's not higher than the 3 I already seen. Then I would take C out the equation. I would go A, B, C, B. So I got another B. So I would backtrack again. Then I got, I know that's another 3. And then B, C, B. Well, I got B. So I'll go back here. This is 2. So this is lower than what I've seen before. So I'm going to just keep track in my mind that the longest that I've seen, the longest substring is what the problem's asking for. The longest that I've seen is 3. And so then I would go to CB. Then I see got another B, so I know that that's not going to work. So I got 2. I know I've seen 3 before. Then I would go to BB. I already got a duplicate right here. So these are actually just substrings of 1 each. So after I'm done with this, I know that the longest one that I've seen, I've kept it in like my memory banks or whatever. The longest one I've seen is 3. So my output will be 3, and that will give me the answer. And so there's multiple substrings in here with 3, but all the problem's asking you for is to give the output of the longest substring, even if there's more than one longest substring, if that makes sense. The first substring is ABC, but there's also CAB, BCA. They're all length of 3, but you just need to return the longest one you've seen. And so thinking about this logically wise, from a logical approach, I know that I'm looking at every, like as I'm looping through this whole string, or as I'm like traversing this string character by character, I know I'm looking at ranges of substrings. I'm looking at ranges within the whole range of the string. And whenever that happens, that problem lends itself to certain tools that you learn when you're studying data structures and algorithms. One of those tools, somebody said it earlier in the comments, is the sliding window technique. Another tool is two-pointer approach. Here, we know that we kind of got a sliding window of a range of characters that we're looking within this string. So when you're in these interviews, a lot of times when you get these problem statements, some of these things, the way they word these problems, it'll stick out to lend itself to a certain approach. And so when you're studying data structure and algorithms, you sort of want to build up a toolbox of algorithms and approaches that you can use to solve problems, and be able to pattern match the questions that are being asked to some sort of solution that you kind of know, and then be able to kind of adapt certain things on the fly as well. Because a lot of times they'll ask you one of these questions, but these companies will throw like a little wrench in there to try to trip you up. But at the core of it, it's the same data structures, it's the same algorithms, it's the same techniques you use to solve these problems. You just got to practice pattern recognition to recognize the patterns in these problems and the solutions that go with each type of pattern, type of problem. So in this case, I know that was long-winded, but in this case, I'm thinking that because of the way I try to solve it in my head, it does seem like a sliding window technique. And the sliding window technique is you're basically looking at a start and an end to create a range, and then you're doing some sort of logic on that range. And then as you move forward, you're sort of sliding the window along like I was doing with my cursor. I was sort of sliding this window along and kind of looking at the different areas to count how long the substring that I'm seeing is after I run into a character that I've already seen before. And so how we can solve this problem is I could simply just loop through this whole thing, right? But what I want to do is create a window that I'm looking at as I'm looping through it. So I actually want to have sort of like 2 pointers to denote the start of my window and another pointer to denote the end of my window. And I want to look at the first character, have both of my pointers start on the first character, and then start to open up my window as I see more characters I haven't seen yet. So when I see this character, I put this character in my window. Then I move my end pointer to stretch my window out. Now I got AB. I haven't seen B before, so I'm going to add B. Then I'm going to add C, I haven't seen C before. I need to always check as I'm adding to my window, have I seen a character before? Once I add A, I've seen this before. And so then what I want to do is start subtracting, closing my window like I did earlier when I was doing it in my head. I want to start cutting stuff off of here until I get to a point where I haven't seen, so I get to the point where I haven't seen the next character. So I start here, I open the window up, and then I want to start stripping off the A because I've already seen the A. And so then I want to strip off that A and stop there. And then I want to start actually adding more. So once I strip this A out, then I haven't seen the A again. And then I want to actually keep adding to my window again. So then I would see a B. Then I want to strip the B out, start here. Then I would add here and see a C. Then I want to strip the C out. So now I haven't seen the C before. Then I want to add B. So I actually want to just keep moving my window. After I see something that I've seen before, I actually want to like strip it out of the front of the window. So I'm going to set up 2 pointers, one at the start, one at the end to denote kind of where the window starts and ends. And as I see something I've seen before, I actually want to go back to the start of the window and push it up to close the window so that I always only have unique characters in the window. Now, what I was doing before when I did this in my head, as I'm doing this, I actually want to be always counting how wide my window is so I know what's the longest substring without duplicate characters. So if I go through my whole string doing this practice that I did, this technique, this algorithm that I just created, as long as at every step I just calculate the longest window I've ever seen, like is this the longest one I've seen, or is this one just lower or the same as the one I already seen? And just always save the longest string that I've ever seen. By the time I get to the end of this, I have this output of the longest character I've ever seen. So that's a long-winded way of explaining it. You probably don't want to take that long to explain it to an interviewer in a real interview. But, this is for the sake of learning. So I'm just trying to over-explain. I hope that makes sense. Let me see and read some comments. Yeah, people talking about the job market. The job market is bad. I understand, like, leak code is in coding challenges. Some jobs aren't asking anymore. I went a long time in my career without actually having to do leak code questions. But once I wanted to start going for FANG companies and certain types of companies, they were asking these questions. So it depends. You can avoid it. You can choose to say, hey, I'm not going to do any interviews with these questions. But it will lock you out, at least today, out of certain jobs in the industry. Now, is that starting to change? I think so with AI coming in, and a lot of companies are stopping asking these questions because they aren't really tied to the day-to-day. It is important to know data structures and algorithms, but they aren't really tied to the day-to-day work for most developers. So I think companies are wising up. But as far as I know today, last time I was in a big interview run, and at least from people I'm talking to that are interviewing now, coding challenges are still prevalent, especially at large tech companies like FANG tech companies, Facebook, Amazon, Apple, Netflix, Google, and Microsoft, like main companies too. The acronym just with Microsoft in it. So a lot of these big and companies that are around those sizes. So you got other companies too, like Airbnb and Stripe and other companies that do this too. Now some of these companies are asking better questions, but it just depends. So we still, at least as far as I know, we still have to learn data structures and algorithms. You still should know them, even if the company's not asking it. But as far as practicing for interviews, I think you still have to practice for it if you want certain types of jobs from certain companies. So that's why I do this. That's why I stay practiced. I'm not the best at it, but I at least was able to pass like FANG level interviews. So I at least got some credit. I don't know everything. I didn't pass every interview. I'm not going to pretend. But, I know enough to at least that I've passed a lot of interviews. So, but I still need to practice this stuff. So that's why I'm on here in front of y'all, potentially about to make a fool of myself trying to do it. But we'll see how it goes. So anyway, I just went on a tangent, but I went through the problem statement. I've explained to the interviewer kind of what my what my approach is. They'll probably say yes, or they'll give me some coaching and say, hey, maybe you should try this. Maybe did you think about that? Sometimes it just depends on the interview again. Sometimes they just don't help you at all. But a lot of times if they're a decent person, they're at least going to try to make sure you're going in the right direction. So All that being said, now we're gonna move into the code finally. I know people probably been waiting or not, but either way, we're gonna move into here. And I'm actually gonna put the problem statement back on the screen at the top, because that was always an issue in my previous streams where people didn't know what the problem was. So now you see it at the top, so that's pretty cool. The one thing I'm gonna change first is LeetCode actually scaffolds out the function that I need to complete. And so this problem is longest substring without repeating characters. LeetCode just go ahead and scaffold the problem out for you. So that this is the function, this is S, this is what they said, you know, I need to operate on. I need to figure out what the length of the longest substring is in string S. So S is a string. I need to return the number, which is the length of the longest substring. The one thing I want to change that I was about to say, change that to const, because every time I get on live, somebody gonna say, why is that var? Why'd you put that as var instead of const? If you know about, you know, const versus let versus var in JavaScript and the differences, you probably shouldn't use var in this case. But LeetCode did that. I ain't do that, y'all. So nobody can come on here and comment that now, because I already changed it on behalf of LeetCode, but I didn't do it. So nobody has to say that. But anyway, so let's go ahead and get started. Like I said in my problem, I'm gonna have to loop through my string, and I'm basically gonna try do a sliding window technique. And if you've done sliding window enough, that's why you have to practice, not practice problems, but you want to practice algorithms and patterns and data structure. You want to learn the fundamentals. I know that sounds boring. I know it sounds like slow, but if you do that, then if you know the fundamental algorithm to solve a problem, it's much easier than just trying to memorize 1,000 problems. I know it sounds counterintuitive. It sounds, you know, boring. It sounds slow. It sounds like you can just skip it, but it's really not a good idea to skip it. Because what these companies do is they take these problems that we answer on LeetCode and they add a twist in it. They add a small difference that if you don't understand the fundamentals, you're not going to be able to pattern recognize. You're not going to be able to recognize that it's the same problem that you solved on LeetCode. You're going to think it's a different problem because they just worded it different, or they put it in a different phrasing, or they added an extra hard little, you know, like twist to the problem that makes it a tiny bit harder, because they don't want you memorizing the problems. They want you to know and that's getting harder and harder now because people have kind of gamified this LeetCode thing, and so it's getting a little bit harder. You're not just gonna get a plain problem. Sometimes you do, but a lot of times these bigger companies gonna kind of like edit the problem a little bit. That's what I'm trying to say in a long-winded way. So anyway, let's go. Let's go ahead and just get started, because I know some people want to see some code or something now. So okay, so the first thing I said I'm going to do is I'm going to implement the sliding window technique, but I'm going to explain exactly what I'm doing. So actually, you know, I'm not even going to talk about the sliding window technique. I'm just going to implement it as I talked about I was going to implement it. So the first thing I usually like to do is I like to longest substring. I like to actually just get my answer variable created. So longest substring length equals, and I'm going to start it with 0 because I don't know nothing yet. And I'm going to go ahead and return it at the bottom, because a lot of times I see people, when I'm interviewing people, I see people forget to do that. And I'm just going to go ahead and start. I know I got, these problems are all about inputs and outputs. I know I got to input S, and I know I need to output this. So this just keeps me focused that at the start of this, I'm doing this, and at the end of this, I need to get here. And so the next thing I'm going to do is, like I said, I'm going to have a window. So I know whenever you're doing a sliding window, you need a start index, and I'm going to start it at 0, and you need an end index. And my sliding window is actually going to be just start at one character at the start, which is index 0. That's always, so it's that sliding window is just going to be one character to start with, and I'm going to like expand it and reduce it and expand it and reduce it depending on the algorithm. So I know this is what I'm going to start with. The other thing I said is I also need, I'm not even gonna do that yet. I'm gonna go in order of just thought process. I'm going a little bit too fast. So anyway, with sliding window, you can do a for loop. You can kind of figure out how to do it with a for loop, but you usually want to use a while loop. And the end index is going to always be where I'm going to end my loop, because that's going to always it's always going to be to the right of my sliding window, because my sliding window has a start and an end. So the end index is always going to be the thing that gets to the end of the loop first. So while end index is less than the length of the string, so that basically means end index can never go beyond the length of my string. Like, that's not a valid case. So I want to stop my loop there at the end of the day. And so now I'm basically traversing the string here, and now I need to do logic inside of here for each character inside my inside of the while loop. And so the other thing that I need to do is I need to keep track of characters that I've already seen, like I talked about earlier. And so how you can do that in JavaScript is create a set, and I'm going to call this scene because these are characters that I've seen. And I'm going to create a new set. This is JavaScript, so this is how you do that in JavaScript. And what a set is when you put stuff in a set always holds unique characters. So when I put something in a set, I can check the set to see if I already have that character in the set, or I can add new characters to the set, or I can delete characters out of the set. And remember, that's what I need to do with my sliding window. I need to sort of like know when I've seen something already and delete things out when I haven't seen it yet either. And so I need to always make sure that I'm always having unique characters that I'm looking at within my sliding window. And so how I can do that is inside the loop is I can say if scene has, that's how I check my set if I have something in it already. I'm going to start with doesn't have. So if it doesn't, like this is just a negation. If it doesn't have, and you also need to know how to access the characters in a string. In JavaScript, you use brackets, and then you set the index of what you're looking at. So this is my index, and where I'm looking at the end index. I'm going to check if I have not, if my set does not contain the character at end index, which in this case would be the first character in the string. What I want to do is, now I got to think about what I want to do here. So if I haven't, based off what my logic was, if I haven't seen the character, what I want to do is actually add it to, I want to say I seen it. So I think I need to do add and just add this in here. So I just want to say that I seen it, because I have seen it, so I need to save it in here as I seen it. It says I haven't, with the if statement, I haven't seen it yet. So I need to say that I seen it, or put it into the set to denote that I've seen it. And then I also need to increment in index to keep this loop going to the next character. So actually what this loop is doing now is every time I haven't seen a character, just add it in here as I seen it, and then in index. Implement the end index to keep looping to the next character, so that when I access the next character, it's the next one, because in index has been incremented, if that makes sense. So and then I need to actually figure out what do I do if I haven't seen the character, or if I have seen the character, like I've seen the character. So this is, I'm not gonna put it in there, but this is scene has index equals true. Just putting a comment there so we know. So that means I have seen a character. So what did I say that I want to do in that case? So like, let's say so my first part of the code I wrote, it sees A, adds it to scene list, sees to the set, then sees B added to the set, sees C added to the set. All this time I'm incrementing my end index. So that's spread in my window. So my start index, I haven't even touched it yet. But my end index, I'm constantly adding to my end index. So I'm actually spreading the window out. So my start index stays at 0, but the end index keeps growing, which spreads this window out, as you're seeing. Then when first time I see A, so that when my code comes in here and it goes into this if statement that I've seen the character already, then what I want to do, like I did in my head, is I actually want to start moving the start index to reduce this, to reduce my window, to cut the first thing off my window and then come into my loop again. So actually when I've seen it, I actually want to, my start index, I actually want to implement that to kind of move my window forward. And the other thing that I need to do is the scene. I need to delete, and I'm trying to remember what do I actually need to delete out of it. Oh, actually, yeah, I need to delete the character that so yeah, I have seen this character, so I actually need to delete it out of scene, because now I'm moving the start index up. I'm gonna delete this character out of scene, say that I haven't seen it, and that will basically moving this start index up, taking this out of scene, and then coming back in this loop. I'll check again. Am I still seeing this character? If not, then I'm going to add this character again, or I'm going to add the next character or whatever. And so I'll still be on the same index, but since I removed this out of here, then I actually will just move on to the next index. So that's good, actually. So what that does is, like, every time I don't see anything, and let me look at this one. So yeah, if I get P here, add it here, so I'm good here. Then I get here and I see a duplicate. Then I'm actually gonna slide my window up and remove the W out. Then I'm gonna say I haven't seen this, and I'm gonna slide this window up. Wait, something is weird, because now I'm thinking, like, when I delete this out, how am I? Yeah, so I'm adding to start index here. I'm actually gonna move this below here so I can kind of understand what I'm doing. And I'm gonna delete. So if I have seen it, and I'm gonna move my start index up. But I'm thinking, like, what about the case when here I move my start index up, but I still have 2 W's in the window? Or do I, I delete the character out of start index. Yeah, sorry. See, that's why you have to think about this stuff. So I think I need to delete the character out of start index that I've seen. Yeah, so then when I loop through again, it won't be seen again because I delete the character out of here. But then, yeah, if I'm here, I delete this P out, but I still have 2 W's, and then I have to delete this W out too. And so that'll start me here. So, yep, that makes sense. So yeah, I almost screwed that up by putting index here instead of start index, because I want to delete the character out of start index, and I want to move start index forward to kind of close my window up. And my set will always just be whatever I'm looking at the current time. And I'll just keep deleting stuff out until I get to the point where I haven't seen the character in my end index. And so, yeah, that's correct in my mind. So I'm looking at this. I think this is it, man. So yeah, I would get to the end of the string. Oh no, this is not it. So now I need to handle this longest substring thing. So if I haven't seen it and I'm adding something to my end index, then no, what did I say? I said at every step I need to recalculate my longest string length. So I'm actually just gonna do that at every step. I probably don't have to do it I probably only have to do it here, I'm thinking, but I'm actually just gonna do it here just to make sure, and then I'll try it at the end to see if I can move it. But basically what I want to do is say JavaScript, you can find the max of two things, and I want to find my current substring length. Substring length. And what's my substring length at any given moment is in index minus start index. That's the window that I'm looking at. I just go from take the right side and subtract the left side of the where it's starting at. Made a mistake there, and that'll give me the current index. Now I need to see if this number, like I said when I was doing this in my head, is the current substring that I'm at, is it longer than the max one that I've ever saw? And so what I want to do is what you can do with JavaScript is use mathmax, and you can compare two numbers, and what mathmax will return is the largest one. So I can just put these both in here, and I can say mathmax give me longest substring length that I already have if it's longer, if it's higher, or give me current substring length if it's higher, and then just set it to make that the new longest substring length. And so by doing that, I get the longest substring length at any time. And so I actually don't even have to have this in another variable. It just makes it more readable. I could just put index minus start index here, but I'm gonna leave this here to make it more readable, and I'll probably delete it later so my code runs a little bit faster. But for right now, I'm just leave it there. So yeah, I think this is it. So I'll keep doing that every time, and by the time I get out of this loop, longest substring length should be the longest substring length, and then I just return it here. And so I would probably do what I just did to the interview. I would talk through my solution, find bugs, stuff like that. I would look at these and say, yeah, all these are, I'm handling a case where it's 0, because if string is 0, like my edge case, if string equals 0, string length equals 0, I'm sorry, then I would just start here, and yeah, this while loop wouldn't even start, because index would not be less than string.length, because they both be 0, and then I would just return 0. So I actually handled that case. But so sometimes when you're interviewing, when you get to this point of the code, you want to kind of read through it and just make sure that it's doing what you think it's doing. When I haven't seen something yet, I'm going to add it, say I seen it in my scene set, and then I'm going to increment this and keep going to the next character, and then do the same operation on the next character. But I'm also going to always check in index minus start index to make sure I'm always keeping track of the longest substring length. If I come back in here and I have seen it, I go down into here, I'm going to actually delete the character at the start index out, and I'm actually going to move the start index up to kind of close my window a little bit, and I'm going to keep looping through and closing my window until I get to the point where I haven't seen the current character again. So I'm going to keep deleting until I delete that character out, and then once I haven't seen the current character again, then I can keep moving my window forward to get a new window. And basically I'll keep on recalculating my longest substring length here, and then I'll return it at the end once index gets to the end of the loop. So that makes sense. So an interviewer, sometimes they'll make you run the code in interviews. Sometimes they don't even have a runner, like they don't have anything to execute the code, and you have to explain it to them. I've been in interviews where I had to do both. Sometimes they have something you can run the code on. Sometimes it's just a notepad where you got to sit there and talk through a problem set or whatever. So I'm actually going to do that. I'm going to talk through this. I do this every time I get on here. How I do this, running this manually, is I set variables in like writing for each variable I have. so I know, you know, what everything, the current value of everything is at any given point. And so I'm gonna put scene here, and you'll see what I'm doing in a minute. Cause sometimes I like to do this on here because sometimes you can't run the code. Like the people will not let you run the code. Like you literally need to, write it out and explain it to them why your code works. They'll ask you like, explain to me how this code, like why you think this code works without running it. And scene is a set, so it looks, I'm gonna display that sort of like an array, a unique array. Everything in it is unique. You can't add something to it unless it's already, unless it's not in there, or you can add to it, but it's not gonna be anything new. It's only gonna keep the unique values you've added to it. That's the beauty, the power of a set. The other thing I can say about a set is very fast to look up whether you've seen something. Like this has operation is very quick because of how a set is indexed and how it operates. It's like a very quick lookup that isn't a heavy load on your algorithm. Basically, it's like big O of n. I'm gonna explain, or big O of 1. I'm sorry, constant time complexity, which I'm gonna explain time complexity, space complexity in a minute. So yeah, so I'm gonna try to run this code. I'm gonna try to run this code manually in my head. So this is my input. This is the test. I'm actually gonna shorten this a little bit because I don't want to. It's gonna take too long to do this whole thing. I'm trying to get through this quick, y'all. But you have to know how to do this. So this is keeping track of all my variables on the screen. So I know that I'm gonna go through this line by line, and just make sure this algorithm works. So I'm actually going to delete all of these and go line by line. So S, we already know that's my input, so that's a given. I can just put whatever test case I want here. So my test case is going to be this. Get to this line, this gets set to 0. Get to start index line, this gets set to 0. Get to end index line, this gets set to 0. So you see how I'm doing it. Get to scene, this gets set. I'm just going to redo that. This gets set to an empty set. Now I'm going to hit this code line. Is index less than string length? String length, I didn't put that down here, but I can put string length is equal to 1, 2, 3, 4, 5, 6, 7. I don't know why I counted that like that, but it's equal to 7. So end index is obviously 0 is less than 7. So I'm going to be able to enter this while loop. Does scene, have I seen in my scene set, does scene set have S at index? So in index, and I'm actually gonna, it can get out of control, but I'm actually going to put a variable for that too, for S index and S start index. So S in index is index, is the string S at index 0, which give you character A. So that's character A is going to go there. So now I'm on this line of code. Is A inside this set? No, it isn't. Or is it not in the set? No, I have not seen it. So I'm going to add A to the set. I'm going to add S in index to the set. So in my set, I'm going to have an A in here. And then I'm going to increment in index. So in index is going to go to 1. And then I'm going to get down here. I'm going to say current substring in index minus start index. Current substring in index minus start index is 1. 1 minus 0 is 1. And then I'm going to say my longest substring is the max of longest substring and current substring length. And so the max between those is 1 and 0. The max is actually 1. So I'm going to just take the highest value, which is a 1, and update this. And so now I'm going to go back to the start of my start of my loop. And is this still true? Yeah, it's still true because 1 is less than 7. So then I'm gonna add. I'm gonna come through here again. Then I'm gonna say S at in index. S at 1 now is actually B, and so I'm gonna add B to the scene list. So now I got B. And then I'm going to increment this to 2. And then I'm gonna n minus start index is 2 minus 0, which is 2, and that is longer, so it's actually gonna update, sorry, to 2. This line here is gonna update it to 2. Then I'm gonna come back into the start events again, and this is gonna be 2, and 2 is C. And so then I'm gonna say, have I seen C? No, I haven't seen C. So I'm gonna go through the same thing again. I'm gonna speed through this part now. Go through the same thing again, where I'm gonna add C to the list. Gonna increment this, remove that. And now I'm gonna come back in here again at 3, which is another A. So I'm gonna come back in here again. Now I have seen A, because it's A now, right? It's S at n index 3, so it's A. I have seen A at this point, so I'm actually gonna skip this logic and go into here. Has seen equals true, which is the else here. So I'm gonna go into here, and now I'm gonna actually delete at the start index. S start index is 0. Yeah, start index is 0, so that's A. So that's A here, and I'm actually going to delete that out of my scene list. I'm going to delete A out of my scene list. And then I'm going to increment start index, which is I'm going to delete that, and then I'm going to increment my start. So I'm kind of closing my window from the start now, which is a little bit different. So I'm closing my window from the start, and yeah, so now I got a different window. And I'm gonna go in here again, and I didn't increment this one, so this one is still stuck on A. Now I haven't seen A because I removed A out of here. So now I'm gonna go in again, and I'm gonna add the A in again, but this time I'm also going to increment n index to 4. And so then I'm gonna do this again, and I didn't do that last time. But yeah, 4 minus, and should I have done that? Yeah, I should have done that last time when I was here. I think, shoot, nah, I screwed that up. Let me see. Because that would have made, yeah, so when I was here, I deleted this out. Yeah, let me go back that again. Delete this out. And I was 1, 3, yeah. Then I was here, then I added to here. And, oh no, wait, hold on. Yeah, so I would have got 2 here. So yeah, I would have got 2, and it would still been 2. And then I would have added to index, which gives me 1. Then I would have came here, added this in. When I saw the A, added this in, added to here. Would have made this 4. And then when I got here, I would have subtracted n index minus start index, would have gave me 3 for this one. And then I would have basically run this line to see which is the max, and I would have got 3 here. And so then I would have came back into my loop again with index 4, 0, 1, 2, 0, 1, 2, 3, 4, which gives me B, which I have seen. So I would come down here, delete my B. Oh no, I wouldn't delete the B. I would delete at the, oh no, I'm sorry, I was supposed to delete that earlier. Let me see, yeah. No, I'm still supposed to keep that. So then I would delete the A from start index here, then increase start index, loop through again. I know I'm not gonna get anything here. Come back again. Have I seen B still? Yes, B is still in here. Now start index is at 2, which is, yeah, I screwed this all up. Cause now I think, yeah, so this is at 1B. Yeah, so I would have removed 0, 1, 2, so it's at C. Yeah, so then I'll be at C, and then has index equals true. Now I would say, have I seen in index 4, which is B, have I seen it? Yes. And then start index, I think start index is supposed to be 1. Yeah, I think I screwed that up, and that's supposed to be 1 still. And then I'm supposed to delete this out here, the B, and it's supposed to still, yeah, I'm supposed to still have A and B in here. I might actually go with like a smaller solution because it's actually really confusing now. Yeah, see, I think I screwed this up. Somebody said something in the comment. I think I screwed this whole thing up by getting confused. So I'm actually going to just move on to a different example because I screwed. Or maybe I'll just start this example over. It's too freaking long. That's why I'm trying to rush through it, because I don't want to sit here and do this example so long. 1, 2, 3, 4, 5, 6. All right, y'all, man. I'm gonna try to get through this faster. I'm sorry, man. Just this is why you have to do these though, because this is like really confusing. All right, but I'm gonna skip a bunch of stuff this time because we know these are gonna get set to zeros. We already know the set's gonna get set up. So we're gonna start here and we're gonna go PW. And so we haven't seen P and W, so we're gonna add PMW to the set. And we're going to increment in index. See, this is what messed me up last time, trying to like skip stuff. So I gotta go through it line by line. Yeah, so I'm gonna start here. In index equals P. We haven't seen it yet. We're gonna add P in here. Then we're gonna increment. That's what's kind of screwing me up, is trying to, I'm actually just gonna like not do this part, because this is what, I'll still do it. So this is 1. And so then I'm gonna calculate my longest substring, will give me 1. And then I'm gonna come back in my loop again. Have I seen in index W? I haven't seen it, so I'm gonna add it here. And then I'm gonna increment this to 2. Current substring is gonna be 2 minus 0, which is gonna raise it to 2. And then I'm going to come back in here, loop again. 2 is W this time. I have seen the W, so I'm gonna go into here. I'm gonna seen delete at what is start index is 0, so it's P. And so I'm actually going to delete scene at P, or delete P from scene list. I'm going to increment start index to 1. Then I'm going to say 2 minus 1 is not greater than 2, so I'm going to skip that. And I'm going to come back here. In index is still W. Have I seen a W in here? Yes, I have seen a W in here. Yeah, so there's a W in here. This is a W. I have seen a W in here. So I'm going here and I'm actually going to delete start index, which is 1 now, which would give me 0, 1, which is also a W. And I'm going to delete the W out of here. So this set is empty now. I'm going to add start index to 2. I'm going to delete that. And I'm going to come back in here. Then this is not going to equal to anything because 2 minus 2 is 0. So come back up here. Have I seen W? No, because nothing's in here anymore. I'm going to add the W again and increment start index to 3. Remove that since it changed. And then this 3 minus 2 down here is not going to yield anything. I'm going to come back to my loop again. 3, 0, 1, 2, 3 is K. I have not seen K, so I'm going to add it. Add a K in here. And I'm going to increment my int index to 4. 4 minus 2 equals 2, so that's not going to yield anything down here. Loop back again. Have I seen int index of 4? 0, 1, 2, 3, 4, which gives me E. I have not seen E. I'm going to add E in here right here. Then I'm going to actually increment int index again to 5. I'm going to get down here. Int index minus start index. 5 minus 2 equals 3. So that is a longer max than what I currently have, and that's gonna be 3 down here, and that's actually gonna raise this to 3. And then this is gonna wipe out, and then I'm gonna come back to the start again. In index 5, 0, 1, 2, 3, 4, 5 will give me W here. Have I seen W? Yes, I've seen W. So now I'm actually going to delete at start index. Start index is at 2, 0, 1, 2. So that's W. And I'm going to delete W out of here. And I'm going to raise start index up to 3 and remove that here. And then, yeah, 5 minus 2 just give me 2. So that's not going to yield anything for that. Then I'm going to come back up here again to the loop again. And I'm going to say, have I seen W? W ain't in here no more. So I'm actually going to add W back again. Raise int index 1. Get down here, 6 minus 3 is still 3. So I'll get 3 here, and that's not higher than 3 that I have, so I'm not going to do anything with it. Then int index is 6, so when I get here, is int index less than 6? No. So I'm actually going to break out this while loop and just return longest substring length, which is 3, which for this problem set, 3 was the output I was supposed to get. So, whew, that took a long time, man. But this is a medium problem, so that's why it take a longer time to explain. It's a little bit. That's why it's a medium instead of an easy. And somebody said, "Dang, I hate coding." Yeah, I get it, man. This one's tough. I'm not even gonna lie. Like, this one's a little bit tough to explain. I'm sorry that took so long, y'all. But yeah, I got the right answer, which is 3, and it's returned here. So going through this manually works. So some interviews I will be done at this point unless the interviewer said, "Hey, I want you to test this with another string." They usually will say that, like they might ask me to test it with BBBB to make sure that I get 1. I'm not gonna do that. I'm exhausted doing that mentally, so I'm not gonna do that. But you might have to do that in an interview. And I probably wouldn't be explaining quite as deeply. I'll be moving a little bit faster in a real interview. But yeah, shoot. I mean, these mediums take a little bit more time than the easies do, so I guess it kind of makes sense to some degree. But yeah, that was a little tough to mentally stay on track with the variables, the sliding window and everything, and just keeping track of the variables. It's easy to get confused. So I'm gonna delete all that. So that seems to work. So some interviews, hopefully you get in an interview where they let you run the code. And so let's test that through. Well, no, before we do that, let's talk about space and time complexity. So we have time complexity and we have space complexity, which are measured or denoted using big O notation. Space and time complexity basically denote how your algorithm performs as it relates to the size of your input. For time complexity measures how it scales in number of operations versus the size of your input. Space complexity measures or denotes how your algorithm scales, how it uses space in relation to how the space scales, the usage of space scales in relation to the size of your input. And the size of my input here is input. You have to know what your input is. You have to study time and space complexity and big O notation. You have to know what the actual input is. And the input here is not just S, it's the length of S. That's what would grow and shrink based on, that's what we have to operate on, is the size of S. As S, let's say S was a 1,000,000 character long string. Let's say it was a 2 character long string. Does my algorithm perform either the same way, or does it perform substantially worse when the size of the length of S increases? A bad algorithm, when I have a lot of characters, may exponentially perform worse for a longer period, for a longer set of characters, based on how I write the algorithm. If the algorithm is exponentially scaling with the size of the input as far as number of operations or its use of space, then that's considered probably a bad algorithm. And so in this case, how you look at that time complexity, is start with that. How you look at that is based on the size of my input, how many operations am I having to do worst case? And here, some operations are constant. It doesn't matter what the size of my input is. I'm always going to do these 4 same operations. If this is 1,000,000 characters, then it's going to be these same 4 operations. If it's 1 character, I'm still going to have to do 4 operations. So these are constant space operations. They don't have any relation in scale up or down to the size of my input. Now here, this while loop, how many iterations in this while loop is going to be highly dependent, or almost fully dependent, on the size of S. So if S is 1,000,000 characters, I'm actually going to have to go through here 1,000,000 times. If S is 1 character, I'm going to go through here 1 time, or none, or whatever. And so this is actually where time complexity is coming in to play, where I know that for at least linearly, for the size of my input, I at least need to do that many operations to complete this, because I need to check every character in here basically to know what the longest substring is. And so now I need to check inside of here, am I doing anything in here any more operations relative to the size of my input? So here, like I said, using a set is a linear operation. It takes constant time to go into this set and check if a character's in here, because of how our sets were created optimally in most programming languages, including JavaScript. So this is just a one-time operation. It doesn't scale based on the size of S. It's still just going to be constant space. Same for adding, still just going to be constant space. Constant time operation. Constant time operation, constant time, constant operation, constant operation, constant operation. These operations don't multiply based on the size of S. They don't scale exponentially based on the size of S. They actually just are always constant. It doesn't matter what the size of S is. And so this is constant. This is a constant operation too. So everything in here is constant operation. It's just here where I'm having to do 6 operations or 7 operations constant, but I'm having to do them 1,000,000 times. So you might ask, is this 1,000,000 times the 6 operations in here? Well, in big O notation, whenever you have a constant number like 6 operations or 4 operations, that reduces down to 1. Because whether this is 1 or 1,000,000 length, this will always just be 4 operations. It's nominal. Whether it's 1,000,000 or 1 length of the string, this will always just be 6 operations. Now this is where it matters, where it's like, okay, if it's 1 or 1,000,000, I'm gonna have to loop through 1,000,000 times. So I know it sounds weird to think that, but 1,000,000 times 6 really isn't. It really is still just constant. Like, if that makes it's like it's not adding anything. Now, if it was a million times a million, now if I was looping inside of here again, a million times a million, now my algorithm is scaling exponentially. But because this is just 6, if I add another operation in here, now it's just 7. You know, and so it's 7 million, but it's as you scale from, let's say it was 70 operations to a million operations, it's not dramatically scaling. It's just scaling, you know, by adding another constant operation. That's how big O notation works. You probably have to go study it. It's hard to explain, but big O notation reduces constant operations down. And so basically this algorithm is linear to the size of my input, and how that's expressed in big O notation is big O of n. So where n represents the length of my input, or the size of my input, which is here is I could say size of the input, which is here, equals n, which equals s. So that's what n stands for. Here is the length. Space complexity. So where am I using, besides for the algorithm I'm passing in, where am I using space complexity? Space complexity is when you create or use a data structure in addition to the original data structure that you use, that got passed into the problem. You create some new data structure, and it is growing relative to the size of your input. Or you have to ask yourself that question: is there a data structure you're using? Are you storing something that is growing or reducing based on, that is related to the size of your input? I'm using this set here. That's the red flag. I'm using this set, and I'm at worst case, if this was a million unique characters, that's not possible within the English language, but let's just say this was a million unique characters, it's possible that I would have to fill this set up with a million things. And so this set is growing and growing in size in direct relation, in linear relation to the size of my input at worst case. And that's the thing about big O notation, is always denoting the worst case possibility. You can't just go off the best case if like all these are just B's and I'm only putting one thing in the set. You have to go off the worst case, if that this set can possibly grow to possibly the size of n based on different inputs. And that's kind of, you have to think about these problems. It's not just these 3 inputs. It can be any input within the constraints. So it could be 5 to the 10th power. So not a million, but it could be 5 to the 10th power, to the 5 to the 5 times 10 to the 4th power. Sorry, which I don't know what the heck that is, but it's some big large number. So y'all can figure that one out. But you get what I mean, hopefully. And so basically, the space complexity is also linear because it can pop, at worst case, it grows with the size of the input, which is n, which is s dot length. And so both my space and time complexity are what are called linear space and time complexity. And I hope that's right. You would have to explain that in the interview. That's a very important part. I explained a lot about big O notation. I wouldn't explain that to the interviewer. They know what it is. I would just tell them why I chose what I chose as the space and time complexity. And I would explain, in the algorithm what it's doing. So these are actually decent for most. If you get linear, then you're pretty much probably in a good spot. If you get big O of n squared, then it means your algorithm is either using space or time complexity is growing exponentially based on the size of the input, which is like a bell curve, like not a bell curve, but it's like an upward curve where it gets worse. The more data you put in, the worse the algorithm performs, which is not great. And so when you get linear, it's just like however much data you put in is how much the algorithm is having to do. And it's just a linear connection, linear relation with the size of the input. So, exponential. Yep. So, yeah, man. Now I'm gonna run this, man. Finally, after an hour, I'm gonna finally run this with LeetCode. LeetCode lets you run this. All right. So I got all my test cases accepted on the first try, which is pretty fortunate. So yeah, this was the one I was trying to do earlier that I just screwed up on. Trying to, hey man, sometimes you screw up. Sometimes it is what it is, but. at least when the code ran it, I still got the right answer. Supposed to get 3 and you got expected 3. I think I was just screwing up with trying to keep track of my variables. Probably could have did that in a better way. BBBBB, you get 1. That's good. This one I actually did by hand. Get 3, which is good. There's another case, which all these are neat. That's why I'm saying, like, if you had 1,000 or 20, 30 characters, you're going to have to count each one as a unique one and put it all in the set, and that's going to grow the space. So here you get 6 because this is the whole string is the longest substring, the whole thing. So yeah, so those are the test cases. So you can run it on LeetCode. LeetCode also lets you submit it, and what they will do is, instead of just running against these 4 test cases, they'll run it against like a bunch of test cases, like super long strings, short strings, weird strings, strings with other characters in it, and they'll compare it to other people that have done this problem on LeetCode. So fortunately, I was able to 987 test cases that they put this through, and it passed 987, which is good. I did pretty good on the runtime memory, but you have to take these with a grain of salt. Like, the runtime complexity, I guess the runtime versus other users. It says it beats 90%, but you can run this. I can run this again and it will give completely different answers. So this is not really. You gotta take that with a grain of salt because it's like varying of how you're running it. But just use this AI thing to analyze the complexity. Yeah, so they said the time complexity is big O of n, like I stated earlier. So I at least was right there. Memory time complexity is also big O of n. The space complexity. So looks like I was correct in that regard, which is really good. So yeah, did pretty good on this one. Got that one right. So I'm actually gonna just move this back over here. Let you look at the code again. We did get a correct answer and everything was good. So at this point, if I was an interviewer, hopefully they would just be like, hey, you're good to go. And it couldn't take me an hour. Like, I couldn't over explain like I've been, but I try to do this for learning, teach people, to provide some value on here rather than just like speeding through the problem. But yeah. But okay, but yeah, I'm gonna answer some questions on here too. And somebody said, Ezra said the space is linear. No, I got linear too. It's definitely linear because it is set. Because worst case, like this test case down here, worst case, I might have to put every character. Like here, my whole thing is unique characters. All these characters got to go in the set. So the length of the string here, 6, has to go into this set. And so this set is actually is using space, is using memory. So if this was 100 character string, all unique characters, this set would actually have 100 things in it, unique things in it. And so that means the set at worst case will grow with the size of the input, which would mean space complexity is linear. Yeah. And says worst case you have a set of 26 alphabets. So it did not say that. That's something you would wanna clarify, right? So it says S consists of English letters, digits, symbols, and spaces. So spaces, I could put spaces in there. I could put symbols. I don't know what this is. I mean, this could be infinite symbols in multiple. It says English language letters, but I don't know if this is English. Like, this could be symbols. This could be infinite number of symbols. I don't know. I mean, I don't know. I mean, I'm sure it's finite in the world. You know what I'm saying? But it could be infinite. So it's not just, if it would have said just S consists of English lowercase letters, 26, then yeah, it would have been constant, like you said. It would have been maxed to 26 possible characters. But when he says you're adding in digits, even with digits, it would have been maxed out to, the number of digits. I guess just 10 digits, English digits. But when they say symbols, I don't even know what that means. Like, that could be anything. And so I think that's why LeetCode is setting this one as big O of n linear. and why this string could actually grow, or this set could actually grow beyond the 26 English characters. So yeah. I think Ezra, you're right. Like in most cases, a lot of these problems would say just like lowercase English characters would be 26, and then you would get space complexity. I think the last time I did a problem, I actually did mess up on the thing you're talking about. So you're right, but yeah, just the constraints are just a little bit different in this problem, so it just changes a little bit. But yeah, if the constraints were written a different way, you would be right, and if the constraints were written the way they are, then it's just different. But in an interview, they might give you those constraints, they might give you different constraints. So it's an important case of where the constraints can actually change the problem, the big old notation a lot. So I'm glad you actually commented that, because yeah, that's very important. I'm a software engineer, you're doing great. Hey, I appreciate that. Fellow software engineer, I appreciate that you saying that. Appreciate the comments from Ezra. Can you solve a hard one? Yeah, I'm gonna do that next time, man. Tonight, shoot, I'm tapped out on this medium, man. I have done hard ones on here before, and it take a long time. It take longer than this for those hard ones. I want to do a matrix problem next, because I haven't done a matrix problem before yet. Something happened to your sound. It went mute. I hope the sound is back on Instagram. Hopefully y'all can hear me. I know people on TikTok can hear me at least. Let's see. Answering some more questions. Java has data types and this one does not. Yeah, so JavaScript is dynamically typed. Java is statically typed. So Java, you have to actually declare the types when you declare variables, versus JavaScript, which is dynamically typed, and it just infers the types from what you actually declare and set it to. So set the variable to. So it's dynamically typed, and it can the language itself, the interpreter for JavaScript, can actually like infer the types, which can lead to issues, which runtime issues where types aren't what you think they are, and typing errors, which is why the TypeScript language, the superset language of JavaScript, was created that's statically typed to kind of handle that. So there's different opinions out there about which is better, TypeScript or JavaScript, but I still like JavaScript. I use it for interviews because I still mostly go for front-end roles. And so to me, I feel like if you're going to go for a front-end role, you need to interview in JavaScript to me. But you can use TypeScript too, or interview in JavaScript or TypeScript. I prefer JavaScript because I feel like if you know JavaScript well enough, then TypeScript, you're gonna be better off with TypeScript. If you understand the problems that TypeScript is solving, then you're gonna be even better at using TypeScript versus just jumping straight to TypeScript and just using it. Because at the end of the day, the browser doesn't run TypeScript natively still, and so it's at the end of the day, browsers still run JavaScript. So anyway, yeah, bro can't figure out 5 times 10 to the 4th power on the fly. Man, I don't know what that is. Hey man, I don't care. I'm not about to sit here and I'm not doing a bunch of math, man. I don't care. I don't need to do math. I just need to do algorithms. Check case where repeating character is not the far left index. Oh yeah, we're talking about all this space-time complexity. What language would you recommend for a cybersecurity major or cloud engineer? What programming language would you recommend for a cybersecurity major or cloud engineer? That's a good question. For cybersecurity, I would actually recommend starting with either JavaScript or Python. For cybersecurity or cloud engineer, I would start with a dynamic programming language, learn the fundamentals, and then once you start getting in deeper, then you figure out if you need to learn another language or not. But I would start with a language that's dynamically typed, easy to learn, like Python, JavaScript. JavaScript runs in the browser, so a lot of cybersecurity issues are done through browser exploits, like cross-site scripting, clickjacking, like all kind of, URL jacking, like all kind of cybersecurity issues happen in the browser. So it may be good to learn JavaScript Python for the back end, because Java's probably really good to learn, but you may want to start with Python. If you're just learning your first programming language, I recommend JavaScript or Python. And so then you'll be able to easily move to another language after you learn the fundamentals. For mid to senior, I feel like you would get in system design questions. So yeah, in an interview, I'm sorry to say, at least when I was doing my last couple interviews, I was interviewing at the senior level, and you still get asked leak code questions sometimes, in addition to system design questions. So it's not like you don't get the system design. You get the system design questions too, and you are expected to perform better on those, but you still get leak code questions too sometimes at some companies. Now some companies are wising up on this, and they're deciding, like for principals and senior engineers, that they're not asking leak code style questions, but a lot of them still do. So it just depends on what company you're going for. Somebody said my eyes turn on dark mode. Yeah, man, I need to turn on dark mode on this. I don't even where do you even do that at? I don't even see it. I probably don't get dark mode because I'm not paying for leak code premium. So yeah, I don't know where that's at. But anyway, yeah, that's weird that it's not somewhere obvious. Unless I'm missing it. This interview is for interns. Shoot. Yeah, this interview is for like mid to senior. Yeah, usually medium problems from leak code and hard problems are kind of gonna lean towards mid and senior. Most of the time for junior, they're gonna ask it easy, but sometimes they'll throw a medium in there too. I've heard, at least from my experience and experience of devs that I know. Yeah, no shame in taking longer to get something completed as long as you learned how to figure it out. Yeah, I appreciate that, man. It takes some time sometimes. Sometimes, yeah, the fact that this is a medium makes me feel good. Dreaming savant, so you must be good at that one. Then this must be an easy one for you. That's good. Once you can kind of suppress those medium ones down, and they feel like easies, then you're on the right track. I hate coding. Hey man, I like coding. I don't like coding challenges, but I like coding. But I like to do them on here to practice in front of people. It's kind of comparable to practice in front of an interviewer. I mean, to doing the coding challenge in front of an interviewer. It's not the same pressure. I'm not gonna pretend like it's the same pressure being an interview, but it's probably the closest I can get without just doing like mock interviews and stuff like that. Because it's like pressure people I don't know that are watching me do it, and I have to explain myself to them and not get confused and not freeze up. That's half the battle in the interviews. I've seen a lot of smart devs fail interviews because they just freeze up. You know what I mean? So, yeah. Please run button is waiting. Yeah, so I was taking so long to run the code, man. They was tripping out. What's up with the Vina project? What's the Vina project? I don't do any one-on-one sessions. I don't really, like, with my content and stuff, I don't really have time to do like one-on-one sessions or anything like that. But maybe one day. Yeah, and then with some comments about how I screwed up the code a little bit. Do you think Gucci Man would F with JavaScript? I don't know, man. I guess Gucci seemed like he used JavaScript before anything else. So, running the debugger manually is crazy. Yeah, man. Yeah, I was. Whew. Yeah, that was tough, man. Running that debugger like that was kind of tough, man. I ain't gonna lie. Like, that was hard. But yeah, I got through it. About to start coding. Where should I start? JavaScript or Python? I suggest. Leak code in JavaScript is absolutely insane. So what do you suggest? Like, I thought JavaScript is a good language for leak code. Like, I feel like it's dynamically typed. It's not Python, but it's pretty simple. So I don't know. I don't get the weirdness around using JavaScript in leak code. Yeah, so Kenny was helping me out on here. There's a lot of comments on while I was doing the coding challenge. I'm gonna go down to the bottom now. I think I done read through all the. Why not system verilog for LeetCode? I don't know what system verilog is. LeetCode and Python 3. I mean, I could, but I work with JavaScript most days, so at work. So I'm gonna use the language that I'm, more comfortable with. You ever monetize a site app for 2-in-1 as side hustle and rev? Yeah. I definitely do a lot of side projects, and so I was able to start some side projects, earn a little bit of side business income. Also put that on my resume. I actually got my first job by doing a side project, like a social media site, and putting that on my resume, and it actually was a real company. I got a real contract. I put it on my resume as freelance work, and that allowed me to get my first job because they were able to go to the site, see it, and was like, oh, how'd you do this? How'd you do that? And I told them how I did it, set up the database and set up the web API layer, set up the front end, what I was doing with it. And it was like, dang, that kind of matches to what we're doing here. And it wasn't all it really was a freelance job. I just wrote a contract with a company. It's like a group of friends, actually, a group of old high school friends. And I created the website and ended up getting my first job with it. And after that, I just kept going, doing side projects and stuff. And to this day, I have some apps on the App Store and side projects. And I've done a lot of apps for other companies and freelance work and stuff like that. But my end goal now is to, I got my full-time job and everything. My end goal now is to create my own apps and services. Keep pushing those till they get to the point where they're generating a lot of revenue and I'm able to have some options. So that's kind of my goal. Yeah, good question, man. Yeah, it makes sense to do in JavaScript since you work in it. Yeah, so I work in JavaScript. So when I go for new jobs, I'm going to match my coding challenge language with the language that's most on my resume. So everything just aligns. Like I'm going for programming jobs that are using JavaScript. I'm usually not going to even, at this stage of my career, I'm usually either going to go for, like I just got promoted to a principal engineer. So that's one step beyond senior at most places. And so at this point, I'm not even so much focused on the particular language. I'm more focused on just delivering solutions and architecting and stuff like that, system design and stuff like that. And so I'm just going to pick whatever language I've been most using. And in the past 5 years, it's mostly been JavaScript at work because we build like web applications. I've been using React Native for my mobile apps, which is JavaScript. I've been using JavaScript frameworks, like JavaScript is where I'm kind of sitting at versus Python, in C# and Java and other languages, which I do know these other languages too. Just I'm not as quite as recently practiced on those other languages where I can do coding challenges from memory. Because whatever language you use in the coding challenge, you want to make sure that you know it like the back of your hand. Like you can't just get on an interview and just be like, oh, I haven't used C# in the last 5 years, but I know it. I think I really know it. I'm going to do it. That syntax is going to kick your butt. I'm telling you. You don't want to be in the middle of a coding challenge. They're hard enough. You don't want to be in the middle of a coding challenge worrying about syntax. Did I write this? How do I do this in this language? If you're in a coding challenge, interview, and you're getting stuck on the syntax, it's an easy way to fail the interview for no reason when you could have just used the language that you were familiar with. So I always stress to use the language that you're most familiar with, and don't just try to use a language just because everybody says, hey, Python's better for LeetCode. Use the language you know the syntax for, even if it's C# or Java or one of these verbose languages. If you're comfortable with it, you need to show the interview that you have a command of the language. You've memorized the syntax. You know what I mean? That's the worst thing I see when I interview people. And they're like, man, I forgot how to access an array, or I forgot how to create a set in C#, or I forgot how to, Like, come on, man. You gotta figure out the problem, and you stuck on the syntax. So that's the only reason I'm saying that is like, just don't get so stuck on the language so much or trying to like use another language for coding challenges than the one you normally use. Like, use the one that you're comfortable with, because I'm telling you, when you get in those interviews in the heat of it, that's the last thing you want to have on your mind, is trying to remember something specific about the language. So anyway, I know I went on that too far. I'm about to start as a new grad soon. How long did it take you to become a principal engineer? 10 plus years. That's usually what it takes to be a principal. You can get to a senior in probably like 3 or 4 years now. I mean, I've seen people get to senior in like 3 years, man. I've seen people go from junior to senior in 3 years, 4 years. But to get to a principal, most companies, that senior to principal is the biggest jump. It usually takes like 5 or more years to jump from senior to principal. Sometimes 6, because in my company, it's like you got to have 10 years plus experience flat. And so, yeah, and you actually have to grow your impact to the point where you're making impact across multiple teams in the organization. You're building solutions that impact the whole organization, not just your own team. And also get to the point where you're making industry impact. So I had to start doing things like submitting proposals to different companies outside of my company that will possibly be used by multiple companies, by millions, hundreds of companies in the industry, like making industry impact outside of my own company. And that'll help you. And, I don't think every principal has done that, but like, at least that helped me. And I think that's what being a principal is about, is like you're driving solutions home. So I know it was a long-winded answer for it, but yeah, it took me about 10 years to get to principal of like pure, experience. So, which is pretty, I mean, I don't know. Maybe that seems like a long time, but to me, I've seen some people don't get to principal to like 15, 20 years, like just depending on where they're jumping around jobs, and it can be kind of tough. So, but there's people that get there sooner, there's people that get there later. I actually could have got there 3 years ago, because I interviewed at a place and they hired me, they accepted me as a principal. And I didn't take it though, and so I ended up having to wait like 3 more years until I got it at my own company. Which, I feel like I'm a better principal now than I would have been back then. I feel like I just interviewed really well, and they were just like, no. What happened was I interviewed as a senior, and it wasn't enough money, and they just said, okay, well, we can't give you any more money unless you're a principal, so we'll just make you a principal. So I was like, y'all kind of like just want to hire me so bad, like that y'all just making me a principal when I really didn't earn it. So it really kind of wasn't, yeah. But anyway, yeah, Eduardo, yeah, transformational impact is not easy to create. Yeah, that's why it takes a long time to get to. At an organization that's treating the principal role correctly, it should take a long time to get there, because you need to build up enough experience and enough know-how and enough kind of self-start motivation to be able to transform organizations, transform solutions, transform products from a technical standpoint, architect new products, re-architect products. Like, it's something I'm still, I'm just becoming a principal. It's something I'm still kind of getting my feet wet in, because I wanted to perform at a principal level before I got there. But now that I'm there, I actually kind of have a little bit more leeway or room to like, do more of what I want in that role. So we'll see how it goes. Dynamic programming. Yeah, dynamic programming, that's kind of like, that's one of the last stops you kind of get to in your journey with coding, with data structures and algorithms. I think it's kind of when you get the basics down, and then now you start building on top of that, where memoization and like storing results and not repeating the same algorithms again to get the same results. And dynamic programming goes kind of deep though. I was doing dynamic programming before I knew I was doing it. What programming language is this? It's JavaScript. And I'm sorry, somebody said the stream is lag. I'm sorry if the stream is lag. It's probably my internet connection. Because I've been on here for like an hour and a half, so it's probably the internet connection starting to lag. I'm making apps using Python. Shadow the Alley Cat using Python to make apps to help with some inconveniences I have. Yeah, that's solving a real problem that you have is the best way to start making apps. And then productize it and see if somebody else got that problem. You never know. You might have the next, big app. Like if you can make an app, like people trying to like go too far sometimes with making apps. Like if you could just simply make an app that could bring in $1,000 revenue a month, that's a win, man. That's a big win. That could change your life. $2,000, $3,000 a month. That could change your life. If you could, that would give you options that you didn't have before. And if you double down on that, if you can get to a point where you're making $1,000 a month, making $5,000, $6,000, it's just scaling. It's just a repeatable process at that point. So like sometimes our goals, it's good to have high lofty goals. I want to make the next Facebook, or I want to make the next Netflix, or I want to make the next big multi-million-dollar app. Sometimes it ain't about that. Sometimes it's about making a small utility app that makes $1,000 a month, $500 a month of added revenue on your job that could change your life, that could change your lifestyle, could give you new options, could really be very impactful. And it's not the big, huge startup dream that everybody else, or the big new tech unicorn company or whatever. It doesn't have to be that. Like just creating utility apps or websites or services that generate a couple $1,000s of revenue a month is a big win. So keep that in mind. It don't always have to be this huge thing. I think Eduardo was talking, or somebody on here was talking about that, which was, I'm glad y'all brought that up. So, what do you use code for? Software engineering. Yeah, I'm a professional software engineer, so that is my like day job. Principal software engineer at this point. Just got promoted, which was pretty cool. Yeah, what's your job? Yeah, so I got my own company. I do like freelancing on the side, so I do have a company for that. But my day job, like my main job, is a professional software engineering job, principal software engineer. So I just got promoted from senior software engineer to principal, which was pretty cool. I also did have a little time being a software development manager, but I decided to switch and go down the IC route, the individual contributor route, after doing management for a little while. I kind of like having my hands on the stuff a little bit better. Like hands-on coding a little bit more, or architecting, or whatever the case is, than doing management. But management was cool too. I miss certain aspects of it for sure. So, what's your best way of figuring out how to code over the years? Best way of figuring out how to code? That's kind of a big question. I would say I'm gonna answer it how I think you're asking it. Is how do I kind of learn new stuff over the years of how to code, like learning new, like keeping up with coding strategies and principles and stuff like that. So I try to be T-shaped. So what that means is I try to know a lot of things, the top of the T. I try to know a lot of things to a surface level. So I try to know about AI tools, about different programming languages and what they do, different frameworks and what they do, different technology stacks and what they do and what they lend themselves to, what they're best used for, different architecture patterns, different cloud infrastructure setups and patterns. Like knowing that stuff at least a high level, so that when I do need to dig down, which is the bottom of the T, like the line in the T, when I do need to dig down, I know where to go because I have a varied experience across a long range. Now you can't know everything deeply. You'll kill yourself trying to learn every single thing deeply. But for me, I know JavaScript really deeply. But I know C# pretty deeply. But I don't know JavaScript as deeply as, I don't know Java as deeply as I know JavaScript. But I know enough about Java to know, okay, next month, if my boss or some company or somebody gives me a task to work with Java, I know enough about it that I can go dig into it and also make it like a T, I can dig down into it. So that's how I practice it. Like I don't try to just go learn everything at one time. Like a lot of people get overwhelmed because like, dang, I need to know JavaScript, and I need to know this, and I need to know React, then I need to know Vue, then I need to know AWS. Now I need to know Azure. Now I need to know how instances on AWS run, and I need to, you get to the point where you feel like you gotta know everything deeply, and you really don't. You really just need to know everything well enough to know when you need to go learn it deeply, if that makes sense. So that's my answer to that. Try Code Academy, yeah, and just find how you learn. That's another thing too. Some people learn by videos. Some people learn are like text-based learners. I'm more of a text-based learner. Like I don't watching videos and pausing and stopping videos ain't really for me. That's why I use AlgoMonster to learn data structures and algorithms for the most part, because it's like a text-based thing. And videos just don't work for me. Like I'm more of a text-based learner, where I like to read and go back and read and go back and read again, and just kind of like see the code on written down. Like watching on the video, it just, I don't know, just ain't my style of learning. But I'm not hating on it, because I know other people, that's the way that they do learn. And so it's about learning the way you learn and optimizing for that. And so that's kind of where I'm at. It's called AlgoMonster, my bad. Let me see if I can type it in without AlgoMonster. Yeah, I kind of do want to plug AlgoMonster a little bit. So AlgoMonster is like very structured way to I'm just reading from the dang site, but structured way to learn how to learn data structures and algorithms. The site, yeah, top lead code. So like they have the patterns on here. That's the most important part. This little, so I like how because they treat you based on the patterns. So what we did today was sort of what's the word? Version of two-pointer approach. Sliding window, where you setting up 2 pointers to create a window. And so, but this basically is teach like dynamic programming is one of the patterns, graph. They basically teach you the patterns with the ROI. And so which patterns do you see in interviews most often? And you learn the patterns in that order. And that's what helped me, because I learned these patterns. Like here's even sliding window right here. So it's not exactly the same as 2-pointer, but it's, to me, it's like a derivative of it. But like you learn the patterns and they give you the return on investment. So like 2-pointer is one of the most important patterns. Sliding window. Somebody earlier said this sliding window problem I just did today comes up a lot. The return on investment is high. And so it makes sense. I'm going to start doing some problems soon. My next couple lives on breadth first search and depth first search and backtracking. I want to start doing some stuff like this. These are a little harder to understand, but they have high investment. And so, you get down to some of these are they're harder to learn, and they come up a lot less in the interviews. And I think it's because some of those interviewers, they don't actually know it as well as they think they do. And so they don't ask too many questions about it. But, once you get in the middle here, this is where the hard stuff, like these companies, like Airbnb was one of the hardest companies I interviewed for. And they kind of got down into this area here, which was pretty tough. But yeah, but it's text-based, but they teach you the patterns. So then they teach you how to recognize the patterns of what you learn, all these different methods, these topics and techniques. And then they teach you how to assign those topics, which you learn, to problems. Like the problems always read in a certain way where you can kind of detect what to assign these approaches to. And so you'll start to be able to detect when you read a problem on a coding challenge, you'll be able to detect when to use the sliding window, for example, when to use breadth first search, for example, or whatever the case is. And so that's why I like AlgoMonster. This site is called AlgoMonster. And that's how it's spelled or whatever. And it's paid. You got to pay for it, but it's definitely worth it in the way they teach you, in my opinion. And they say it's 50% off right now. So, because I even tried to get an affiliate code for them. I was like, I'll start plugging y'all, man. They ain't give me no affiliate code. So I'm still just plugging them for free. But it is what it is. But yeah. So yeah, man, Eric, it's AlgoMonster. I definitely recommend it. There's Algo Expert out there, another one called Algo Expert, it's all video based, and I don't know, man. Them videos, I just can't learn as well from. I like to see the text so I could copy and put it in other places and like memorize it in my head. You know, I don't know, man. Text is just easier for me to kind of stick with my head. So yeah, how does AI play into your workflow? That's a good question, man. Catch these visuals, Instagram. That's a great question. So now we are I'm not gonna talk about, well, let me see how I want to answer that. Let me think about it. Yeah, I'll talk about it. So how does AI play into your workflow today? So at work, we're being pushed to utilize AI a lot more in our workflow. So we're actually starting to install AI tools into our development environments. And it's expected now that you use AI. Like, it's not cheating or anything like that, at least in work. It's expected to use it. You should be producing code faster than you have ever been able before. You should be producing code with less issues in it because the AI should be double checking you. And you should just be like doubling your work output because you're using AI to deliver things. You should be able to deliver things even some things that you're not as familiar with technically how they work. And you should be using it to teach you. Like, that's the most important thing to me, is using AI. You know, getting the work done is number one, of course, but using it to teach you versus it just doing everything for you. And so that we're actually being expected to do that at work. So on my own personal projects, I also use AI. I've integrated it into my IDE, into VS Code. So I'm using GitHub Copilot right now. I'm using that one for a while. I'm gonna see how that goes, and I might switch to another one. But right now, GitHub Copilot, I pay for the whatever the pro version is. I get to use Claude Sonnet within it, which is pretty good at coding. And so yeah, man, I was able to just prompt it to, like, I had this mobile app that I had where it had a custom keyboard on iOS. And I also needed to develop the custom keyboard for Android. And based off the code I wrote for iOS, I prompted and said, hey, look at the code I wrote for iOS. Look at the design. Look at how it looks. And convert this into an Android keyboard with the same functionality, the same style, the same look. And it did pretty good. It went and analyzed my code in the IDE. It had all the context of my code. And it created new code. And I could review it. I could fix things. I could accept it. And I could keep tweaking it when there were bugs in it. And so yeah, that's pretty much how I'm using it. Like, I'm actively using it. I haven't taken over my job, but it's definitely heavily assisting my job right now. And so the other thing on top of that is what was I gonna say? Yeah, I mean, we're just getting pushed to use it a lot every day. It was some other point I was gonna make, but I can't remember now. But yeah, that's a great question. Great question. How much of a code would you say is generated by AI? Ooh, that's a good question. I'll probably say for me, it's probably like 50% at this point, which may seem like a lot, but for some people it's like 90, like 100%. Me, it's like when the AI delivers the code, I'm kind of I'd say I'm kind of a perfectionist. So like, if I see the AI wrote something weird, I might go in there and fix it, you know. So then when I go in there and fix something, I consider it as my code. Because, I mean, the thing is, it's not too different from what we used to do, right? Coders used to use Google a lot. We used to use Stack Overflow a lot. We still do to some degree. We were copying code from documentation. We were copying code from Google. We were copying code from Stack Overflow and adopting it for our uses. AI is basically doing the same for us, but it's just supercharged. It's a lot faster. It's a lot more contextual. It gives better results than those other things ever did. But at the end of the day, we still going to review the code. We're going to tweak it. We're going to kind of fit it into what we're trying to do. And so it's kind of that's why I say 50-50, because it's kind of the way I'm tweaking the code sometimes, I kind of make it my own. But I mean, I prompt as much as I can at this point. And somebody on YouTube said coding is dead, prompts are the future. And that may be the case, but I think that, you know, our jobs might change, but being a software developer There's a reason they don't call us anymore. They don't call us coders anymore. They don't call us programmers. In our, like, my actual title at my job is not a programmer. It's not a coder. So it never was. It never was for 10 years now, like 15 years. It's a software engineer or a software developer. So how I develop the software, maybe I'm coding, maybe I'm writing literally lines of code, or maybe I'm copying the code from somewhere and putting it together, or maybe I'm generating the code with AI. I'm still engineering software. So at the end of the day, yes, AI may take over and do it one day, but for right now, the one thing I'll tell y'all about the experience I've had with AI so far is that it still is not there yet. I don't. People will get on here and preach all day that it's like, man, it's gonna take over everything and your jobs are gonna be gone in a year. I'm not seeing it, man. And then somebody will come in the comments and they'll say, did you try this one? Did you try that one? I tried a lot of them, and I talked to a lot of people that's tried a lot of them, and it's, when you're watching something when you're watching AI do something for you, and you're able to kind of like push it in a direction and fix it and do this and do that, it may seem like it's doing a lot, and it is, but you're still helping it, and you're stopping it from going down bad paths. What I notice about AI is once it gets on a path, if there's no human there to stop it and get it on the right track, to like prompt it back the right way, it will go out of control. So fully automated agents, it's just not there for me. I couldn't even, it was hard for me to even get this thing to do a perfect, I'm watching it do it and I'm telling it what to do, and it still wasn't doing certain things right. It was still certain times I had to jump in and fix the code myself. It just, no matter how much I prompted it, it just wouldn't fix it. And these are using like some of the best coding models out there. Like, this ain't just me just using, trash GPT. Like, I'm using like, some of the good ones. So, or the ones that everybody say are good. So it's still not there yet. It's still room for software engineers, at least as of today. But it's going to grow fast. I know it's going to be exponential improvements and all. I've heard all that stuff. And I believe it too. So, it is what it is. But for now, I'm just going to keep going the way I'm going. I feel like the people that win are the people that upskill. So I'm going to keep on learning the new tools. I'm going to keep getting better as a programmer at the same time. And I'm confident that I will have the skills to succeed in the industry, no matter what happens. So that's just kind of, I don't have any other choice. What other choice I got? Because it's like the doom and gloom thing. It's like AI is going to just destroy everything. It's going to destroy code. It's not going to have any job. And then that's the end of the conversation. And it's like, that's where you ended at, is that AI is going to take your job and you just going to sit on your hands and just be done. Like, there's no choice but to keep trying. So, why else? Did you end up solving this? I was gone for a bit. Adam, yeah, I ended up solving it a long time ago. I'm just answering questions now. Dude, where are you from? I'm from Atlanta, so that's why I got a little bit of country. I'm trying to code switch for y'all. I'm trying to like talk professional, but that Georgia country, from the countryside, I moved to Atlanta probably like 15 years ago, whenever, and so I'm country boy at heart, so that's why the accent gonna slip through sometime. But yeah, I'm from Atlanta. I don't like the juice. I don't know what the hell you talking about. The juice. I was trying the problem as well. Did you mind explaining the solution briefly? I don't know when. That was probably like 30 minutes ago. I had the sound muted trying to solve it. The solution for this one, I can explain it briefly. Length of a longest substring. You see the question up at the top of the screen. Without duplicate characters. You basically want to use a sliding window approach. You want to open up a window. You want to, as long as you're seeing unique characters, you want to open up this window and always keep counting how many characters you've seen that are unique. You want to keep a max of the largest window you've ever opened as you loop through the string that you're looking at. As you see characters you've seen before, you want to shorten the window from the front, and then you want to keep going and raising it from the back again. And once you see a character you've seen before, you want to keep shortening it from the front until you don't see a character you've seen before. And if you keep moving this window through the string, and keep recalculating at every step the longest window that you've ever opened up, eventually you'll get to the end of the problem and you'll have this variable with the longest substring length, which is what they want you to return in the problem. So I hope that makes sense. It's a medium problem, so medium problems are harder to explain, they're harder to understand, and that's why you kind of work your way up to them with easies. So yeah. But yeah, I appreciate that question about the AI. I appreciate the question about the coding challenge. ChatGPT can code a whole software without you being there. Yeah, it can. It can, but so this is the thing, man. I don't know if you're a programmer or not, but this is the thing. Yes, it can code without you being there, but it works better when you're coding something new. See, what you're talking about it can just code some new app for you, brand new, and then it spits it out. Now, the thing I want you to think about is, does it have issues in it? Do you know if it has issues in it? Does it have security holes in it? Did you test it? So when you get a real programming job, it's not just about building new stuff all the time. You're building on old products that have old requirements, that have test cases, that have millions of dollars behind them, that have performance impacts. They need to perform a certain level or the company will lose money. They don't need to have security exploits or the company can get sued. They don't need to have bugs because the company can lose money on bugs. Like, those are the things. Like, yeah, you're just letting it run. But what I've noticed as a real software developer, when I look at what it builds, it's not always 100% correct what I prompted it to build. And sometimes it doesn't have the context it needs to build it properly. And so when you work for a company, you're working with 10-year-old code. You're working with millions of lines of code. When AI has to build within the context of millions of lines of code, it needs to know what those millions of lines of code is, and AI right now still has a context problem. It costs AI companies a lot of money for you to prompt it and add in all that context of all the code that currently exists at the company. That's why they have this thing called context window for most AI models, where it looks at only a certain window of the code when it makes a decision. Because it does not have all the context, it can make mistakes just like a human can, and it will make mistakes. And so, yes, when you're building something brand new, it's easier for AI to do it. But when you're working within a company and you need to build something that has to hook into other things or you're building a new feature or fixing a bug within a current system that has constraints, the AI can't just do whatever it wants. And so that's when you have complications that come in. That's the difference I'm seeing between people that are just coming into the industry, and they're just like building new stuff with AI, and they think, oh yeah, this is how it's gonna work forever, and this is how all software development is. No, that's not how all software development is. You're not always just building new stuff and just letting AI just build a bunch of new stuff. Like, you gotta have the AI give it context and plug into stuff that exists and fix real world issues. And so, yeah, that's just my take on it. I don't mean to get kind of like ranty on it, but that's kind of what I'm thinking. Now, I mean, I'm talking against AI, but do I think AI is eventually going to start pushing jobs out? Yeah, it already is. It's already pushing jobs out now. Will there be a day when AI is completely working on its own and solving problems? Yes, there will be. But I'm just saying right now, it's not there yet. That's all I'm saying. It's not there yet. But I mean, it's getting close. It's getting closer. And even when it does, it doesn't mean that everybody will just be running unsupervised AI agents. It still will be supervisors or prompters. So just to think that we're just going to have like Skynet and it's just going to be coding stuff and there's nobody going to be working at the company anymore, like, that's a little bit much. That's a little bit aggressive thinking. But yeah. I mean, this automated stuff is coming, but it's just, I still think it's going to be supervised. I think you're going to have, like, where you used to have 6 developers on a team, you might have 2 developers and 4 AI agents running. And the thing is, it's not free. You know what I'm saying? That's the thing people not thinking about. Running automated AI agents is not free. It costs money. Like, it costs money too. You know what I mean? And it's not always like, and it's expensive on resources. Like that's why these companies they give you limits with prompts. Like you can't just set up 1,000 AI agents and then just replace your whole team, because these companies give you monthly limits, because right now a lot of these companies are building data centers and stuff right now and trying to improve the electrical grid to support the amount of AI that's going to be needed to be processed in the future, like AI prompts and machine learning and LLMs and all that stuff. And so right now they're pushing that back with just raising the prices and setting limits on the prompts. Cause like even at my company, like the tool we use it maxes out at like per month. Like you can only give it like so many prompts, or you can only use so many tokens, and it maxes out. So it's like it's already limitations, and people still saying like, hey, it's gonna take over your job tomorrow. And I'm like, it's like limitations literally on the website. It tells you what the limitations are. So I'm not trying to like be this dude that's like, oh, it's my job, and I'm just trying to be like, AI is not gonna change my job. Like it is. It's already changed my job, and I know it's gonna change a lot, and I know it's gonna take over a lot of things. I know that, but I'm just saying, let's not be unrealistic. Like, you know what I'm saying? It's fun to talk about how it's just going to take over everything, but it's also like, you know, we still got to be realistic with the cost and the resources that to be used. So, yeah. And somebody said LLMs have never been economically scalable under the current paradigm. Yeah. It's just, yeah, man. It's still going to cost a lot of money. It's not just, oh, we can get rid of the developers and then we don't have to pay nothing. We can just use AI for free. Like, that's just not how it's going to work. And the AI, you know, I mean, it's definitely taking jobs right now for sure. Like somebody just said in the comments, like it's taking jobs for sure. I mean, that's what I think is going to happen. Like, I think it's going to be taking the jobs, especially junior developers. It's going to be less developers. And software developers are going to be doing less coding, like for sure. You're going to be doing more prompting, but it's software engineering. We never were called programmers in the first place. Programmers are people that learn how to code, but when these jobs, like look at all the jobs, like go on LinkedIn and look at all the jobs. They're not saying programmers, they're saying software engineers, software developers. So our tools are changing, but we're still just engineering software. So we'll see where it goes. And the other thing I'll say, I mean, I know there's different opinions. Yeah, AI hallucinates right now. There's a lot of hallucinations still going on. I know it's getting better, y'all, but it's still a lot of hallucination that are going on. And if you don't have a human in place to stop it, and you just have it just running automated, it will just keep going. It's like if you had a robot that was digging a well for you, and it was supposed to be digging straight down, and then it said, oh, it's a rock right here, so I'm gonna start digging sideways, and it just kept digging sideways, and it just never got the well done because there's no human to stop it from digging sideways. It's just gonna keep digging sideways. That's what AI is doing at this point if you don't have human intervention. And so, but, you know, hey, what do I know, man? You know what I'm saying? I don't know. But, yeah, there's a lot to think about with it for sure. The last thing I'll say about the AI thing, too, is that, you know, I believe one day that AI will be able to do a lot of things for us, and maybe it will just kill programming jobs. I mean, I can see it. I can see it happening. But if that day comes, will we really be focused on programmers? Like, will we really just be like, man, would that be the hot news of the world? Is all programmers lost their jobs to AI? It won't be. It won't. Programmers will be like the least of everybody's trouble at that point. If AI can take over programmers' jobs, the amount of jobs it can take over once you start building, you know, you start integrating the AI into robots and robotics and stuff too. Like Elon has this plant, he's building robots. Amazon's building robots. They replace a big portion of their warehouse employees with robots. Once you integrate the AI with these robots, we're not going to be thinking about programs. We're going to be thinking about the whole economy and all the jobs. So it's like the focus on programmers is due to proximity, because programmers are the one working on the AI, and it's an easy use case to study for AI. But if that happens, I hate to be like that, but if it does get to the point where that happens, programmers aren't going to be the only ones that jobs are going to be replaced. Like, it's going to be the least of everybody's worries for sure. So, I'm not sure why the programmers, like, there's so much fear mongering around the programmers. To me, right now, it's the latest tool for us to use. It's a very good tool, very powerful tool, and that's how I'm using it. And until I know further notice, I'm just gonna keep working, and keep learning. So that's all I can really. I mean, what else can I do, man? You know what I'm saying? I can get on here and jump on the boat of everybody else, and I can say, man, my job's gonna be over, and I can just quit. I can just go to work tomorrow and say I want to quit. That's what I'm trying to figure out, what people expect me to do. Just go to work and just quit? Like, I think it's a lot of fear mongering, but it's like no solutions. It's just like, I'm just going to stop learning. I'm not going to do anything. I'm not going to get in the program. I'm not going to learn any skills because AI is going to take over everything. Do you think you're going to be better off by just stopping improving your life in any way? You just going to say, I'm not going to improve my life or my knowledge in any way because AI is going to take over everything anyway. So I'm just going to stop improving life at anything anyway. And I'm just going to just sit around all day. Or I'm going to, I don't know. Because there's nothing that's safe. I don't care. Y'all can come up with stuff, and I can give you how AI can take it over if you add robotics into it. Because people always go to plumbing and roofing and all that. If you saying AI can take over a programming job, you think an AI in a robot couldn't do a plumber's job? You know what I mean? Like, come on, y'all. You know what I'm saying? So it's just I don't get it, man. I really don't get it. But I'm just ranting at this point. Regulating AI. Yeah, I mean, that's a good question, man. So because we have, we're competing with other countries, right? We're competing with, folks over in other continents, Asia, those countries over there. You know what I'm saying? We're competing with European countries. So even if we created regulations over here in the U.S., now we're just getting behind other companies. I don't see the U.S. doing that. So I don't see the U.S. regulating AI by themselves. If the other country's not going to stop, we're not going to stop. And so then it comes a question, are you going to regulate AI at like a global level somehow? But then it just becomes the same issues we fight over today. It just becomes a new issue that we're just going to fight over. How much do you regulate AI? There's other things that are being regulated at a global level that are being fought over right now every day. I'm not going to say it on the stream, but there's other things that get regulated globally or try to get regulated globally. So to try to regulate AI and try to say, oh, you can't use it for this, I don't see it happening. That's my opinion on AI regulated. I don't see anybody regulating AI. Technological progress, I don't see how it gets regulated at all. I've never seen technological progress get regulated properly without, some fighting or something. I don't know. But I know one thing, the U.S. ain't going to get behind they're not going to let these other countries get ahead. So if it can't be regulated globally, then everybody's just going to keep moving at their own light speed, rate. So that's my opinion. But yeah, we can have some kind of treaty or something, but treaties get broken. We have treaties today for other things, and they get broken. And companies work on things that they're not supposed to be working on, and so it's just in secret, or whether they do it in the light, and we just start fighting over it, and other countries fight each other over it, and I don't see this as any different. Like, I see AI is the thing that's going, the country or the societies that progress the furthest on AI will probably be the future. They probably be the most successful or most dominant countries in the future. And so I don't see any country choosing to stop and I'm not saying, I know regulation isn't stopping progress, but regulation can get in the way of progress at times. The way that AI is being talked about being regulated, it will get in the way of progress to me. So that's why I just don't see it being regulated heavily. I mean, shoot, they ain't even regulating. I mean, they halfway regulating Bitcoin. They barely regulating that. So, I mean, I don't see how AI gets regulated. So that's just what I see. But, yeah. Do you think I could learn if I have no experience at all with coding? Oh, yeah. Yeah, I mean, can you learn to code? Or, yeah, especially now. And that's what I'll say, too, about AI. AI, you can build at super speed, but you can also learn at super speed. Like, because it's not much different. We think it's so much different than before. It's really, like, we copied a lot of code. Like, I've been a developer for, like, 15 years. I copied a lot of code from documentation websites. I copied code from Google. I copied code from Stack Overflow. So copying code ain't new. Using code that I didn't write isn't new. It's not new. It's not new at all. Now, did I write more code before AI? Yeah, I wrote more code myself. But copying code isn't new. Reviewing code, software developers review and read way more code than they write. And that's historically always been it. We read more code than we write. And so it's always been that way. And so I will say that, I got off a tangent, but I'll say that right now is the best time actually to learn how to code, because AI can teach you exactly how you want to be taught. You can tell it to do something for you, and you can also tell it to tell you how it did it and explain to you the fundamentals behind how it did it. You've never been able to get ask such direct questions and get such a direct answer to teach you something as you ever been before. And so now is actually the best time to learn the code, the fastest time to learn the code. I can see somebody learning the code in months now, like being really good coder in months now, versus where it used to take like a year or two to really get proficient. Like, I can see it happening if you're technically inclined. I can see it happening in months now if you're really every day just hounding it with AI and just coding and practicing. So it's a solid place to learn how to code for free online. It depends on the language. There's Free Code Camp is pretty good. Let me see. There's something. YouTube is always good if you're like a YouTuber. If you like to use YouTube a lot. Free Code Camp is good because it's free and it's really high quality for $0. That's for compared to how much you're paying. There's JavaScript, I think 25 if you want to learn JavaScript. But there's just, I can't even list. There's so many resources now. I recommend learning through AI. Like, even asking the AI, just be a teacher, just run me through something. But like, if you want something streamlined, Free Code Camp. I think there's something called Egghead. It's pretty good. YouTube, of course. Find a good YouTuber that you like, and just there's so many courses from start to finish on how to learn how to code. But I would suggest starting with either Python or JavaScript, depending on if you want to go front end or back end. JavaScript for the front end. That's the languages I always recommend to people to start with, because they're easier entry level entry points. And yeah, so yeah, it's a good question. But yeah, man, I've been on here 2 hours. I think I'm gonna get off of here now. I probably made people mad with this AI rant. Hey, I know AI's coming. AI probably gonna take my job. If that's what y'all want to hear me say. AI's gonna take my job. I guess it's gonna take my job. Some of y'all want to hear me say that. Some of y'all been like on in the middle, and some of y'all on closer to where I'm at with it. But just from what I see, man, it seems like it can, but I just think my job is just gonna change to being more of a AI prompter. But I still gonna be building software. It's just I might not be doing the coding. You know what I mean? The AI agents may do the coding, but I may just be setting the AI, directing the AI agents on what to do and stopping them from hallucinating and doing stuff we don't want them to do. And when we make that's the thing about a business. Business ain't always just set something off and just let it go run and just code. Sometimes you let it go, and then the business says, "Oh no, we don't want to do that." And then you have to tell it to backtrack, and you say undo this part, and then you have to tell it to do it again, and then we have a customer that wants this. That's stupid. The customer wants something very stupid that nobody would ever do in their life, but they're paying us, so we got to do it. The AI is saying, "No, that's stupid. I'm not gonna do it because that's not smart." But you got to tell the AI to do it because the customer wants it. So real business ain't as simple as just spinning off an AI process and just letting it do whatever the heck it want to do. You know what I mean? Real business and software development requires trade-off and decisions and communication and translating real world problems into technical solutions. You know what I mean? And so sometimes I think there still be a place for the human in that process, whether they're coding or not. But, that's enough about that. I'm done with it. WUNC program. I appreciate it, man. Licensed scammer. I appreciate that. I appreciate everybody jumping, especially on TikTok, Instagram. It's like 1 or 2 on there every now and then. YouTube. I'm on all the channels. I'm on Twitter. I'm on Twitch, Facebook, YouTube, all of them at the same time. So you can follow me on and watch on all those different channels. I try to do one of these a week. I'm gonna try to start streaming more often, multiple times a week. Follow each other that you've talked to in the comments. Follow me. DM me if you have questions that I couldn't answer. Follow me, all that stuff. I got post content. I post social media content about tech industry and coding and stuff like that and AI every day or a lot. So, yeah, man, just keep up with me. And I will see y'all in the next live. I'm about to lose my voice, so I'm going to go ahead and get off of here. I really appreciate everybody who commented, anything you commented, like whatever it was, like all the opinions are valid, and I appreciate it. It leads to very good discussion. And yeah, really appreciate it. Yeah, I'll talk to y'all soon. I'll see y'all in the next video.